February 20th, 1944, Big Week commences over Nazi Germany. 1,000 American heavy bombers launch from English airfields, the Boeing B-17 Flying Fortress and Consolidated B-24 Liberator formations climbing toward 25,000 feet. The Norden bombsight computers calculate wind drift and target coordinates. The objective is precise: systematically destroy German aircraft manufacturing before the Normandy invasion. If successful, Allied industrial technology will shatter the backbone of Nazi air power. The war in the skies above Europe had become an industrial contest of unprecedented scale. By early 1944, the combined might of American precision daylight bombing and British Royal Air Force night area attacks was grinding German war production into rubble. The strategic bombing offensive represented the largest application of air power in human history, with over 18,000 American heavy bombers and 7,377 British Lancaster bombers systematically dismantling the Nazi war machine from 30,000 feet above. The technological revolution that made this possible began in American aircraft factories during the late 1930s, where Boeing engineers designed the B-17 Flying Fortress around a radical concept: a heavily armed bomber that could fight its way to distant targets in daylight, deliver precision attacks using the top-secret Norden bombsight, and return home despite enemy opposition. The four-engine design represented a quantum leap in strategic warfare capability, combining unprecedented range, bomb capacity, and defensive armament in a single aircraft. 20-year-old Staff Sergeant James Lee Hutchinson, a radio operator and gunner with the United States Army Air Force's 8th Air Force, climbed aboard his B-17G Flying Fortress at Royal Air Force Bassingbourn on that frigid February morning. The aircraft, nicknamed Liberty Bell, carried 1350 caliber M2 Browning machine guns distributed throughout gun turrets and positions designed to create interlocking fields of defensive fire. Hutchinson's crew represented the average age of American bomber personnel. Most gunners were teenagers, while officers averaged 24 years old. The industrial scope of the American bombing effort defied comprehension. Boeing, Douglas, and Vega manufactured 12,731 B-17 Flying Fortress bombers during the war, while Consolidated Aircraft, Ford Motor Company, and other contractors produced 18,482 B-24 Liberator bombers, making it the most manufactured American aircraft in history. The Ford Willow Run plant in Michigan alone employed over 40,000 workers operating around the clock, producing one B-24 Liberator every hour at peak production. Inside the cramped confines of his B-17, Hutchinson monitored radio frequencies while manning the right waist gun position. The Boeing B-17G Flying Fortress measured 74 feet 4 inches in length with a wingspan of 103 feet 9 inches, but the pressurized crew compartment provided barely enough space for 10 men and their survival equipment. At bombing altitude, outside temperatures plummeted to minus 60 degrees Celsius, requiring crew members to wear electrically heated flight suits and breathe supplemental oxygen through masks connected to onboard systems. The formation climbing through English morning clouds represented the culmination of American precision bombing doctrine developed during the interwar period. United States Army Air Forces planners believed that heavily armed bombers flying in tight defensive formations could penetrate enemy airspace without fighter escort, locate strategic targets using advanced bomb sights, and destroy them with unprecedented accuracy. The theory assumed that precision destruction of key industrial bottlenecks would cripple enemy war production more efficiently than the area bombing tactics employed by other air forces. British Royal Air Force Bomber Command had pursued a different technological path after discovering that daylight bombing missions over Germany resulted in catastrophic losses. The RAF switched to nighttime area bombing using the magnificent Avro Lancaster, a 4-engine heavy bomber that could carry up to 22,000 pounds of ordnance to targets across Nazi-occupied Europe. With a crew of 7 and powered by 4 Rolls-Royce Merlin engines, the Lancaster became the backbone of the RAF night bombing offensive against German cities and industrial centers. Flight Lieutenant William Morrison of the Royal Air Force 617 Squadron prepared his Avro Lancaster for a precision night attack against the Messerschmitt aircraft factory at Regensburg. The Lancaster bomber, designated Dambuster III, carried specialized equipment for precision bombing missions, including the Mark 14 bombsight and radar navigation aids that allowed accurate target location in darkness. Morrison's crew had trained extensively for precision attacks against specific industrial facilities, representing a merger of British night flying expertise with American precision bombing concepts. The Lancaster aircraft surrounding Morrison represented one of the most successful bomber designs in aviation history. 6 major companies built 7,377 Lancaster bombers at 10 factories across Britain and Canada, employing over 11 million workers in 920 companies that supplied components and materials. The industrial organization required to sustain Lancaster operations exceeded that of any other British aircraft, with more service personnel involved in flying and maintaining Lancasters than any other Royal Air Force aircraft in history. As Morrison's Lancaster climbed toward operational altitude, German radar operators at Luftwaffe ground stations tracked the incoming bomber streams with increasing precision. The German air defense system had evolved into a sophisticated network of radar sites, fighter bases, and anti-aircraft artillery batteries designed to counter the growing Allied bombing offensive. By 1944, the Wehrmacht operated over 10,000 88mm flak guns throughout occupied Europe, with each gun capable of firing 15 to 20 rounds per minute at altitudes exceeding 30,000 feet. Hauptmann Franz Stigler of Jägerschwader 27 received the scramble order at his airfield near Regensburg as Allied bomber formations approached German airspace. The veteran Luftwaffe pilot climbed into his Messerschmitt Bf 109G fighter, one of over 12,000 single-engine interceptors defending the Reich against the daily onslaught of Allied strategic bombers. Stigler had already achieved 28 confirmed aerial victories, including 5 4-engine heavy bombers, but the mathematical reality of air combat was grinding down even the most experienced German pilots. German aircraft production facilities had become primary targets for the combined bomber offensive following the Casablanca Conference Directive of January 1943, which called for the progressive destruction and dislocation of the German military, industrial and economic system Operation Point Blank. The systematic campaign against German aircraft manufacturing aimed to destroy fighter production and eliminate the Luftwaffe as an effective fighting force before the planned invasion of Western Europe. The Messerschmitt factories that Stigler defended produced approximately 14,000 Bf 109 fighters during 1943, but Allied bombing was systematically reducing production capacity across the German aircraft industry. Intelligence estimates indicated that sustained attacks on airframe factories, engine plants, and component manufacturers could reduce German fighter production by 60% within 6 months, creating the air superiority conditions necessary for successful amphibious operations. American formation flying tactics had evolved through bitter experience during 1943, when unescorted bomber missions deep into Germany resulted in catastrophic losses. The infamous Second Schweinfurt raid of October 14, 1943, saw 60 of 291 B-17 Flying Fortress bombers shot down by German fighters and flak, earning the designation Black Thursday in 8th Air Force records. The 22% loss rate proved that daylight bombing without fighter escort was mathematically unsustainable. Sergeant Major Wilhelm Hoffmann commanded an 88mm Flak 36 anti-aircraft gun battery positioned on the outskirts of Schweinfurt, the ball-bearing manufacturing center that Allied planners considered crucial to German war production. Hoffmann's 4-gun battery represented part of the massive flak network defending German industrial targets, with each 88mm gun capable of firing 17-pound high-explosive shells that burst into over 1,500 steel fragments at predetermined altitudes. The German 88mm flak gun had evolved from anti-aircraft artillery developed during the 1920s by Krupp engineers working at Swedish Bofors facilities to circumvent Versailles Treaty restrictions. The Flugabwehrkanone 1836 and 37 models became the backbone of German air defense, with their high velocity, rapid rate of fire, and devastating effectiveness against aircraft at altitudes up to 35,000 feet. Allied airmen learned to fear the distinctive black puffs of smoke created by exploding 88mm shells, knowing that any aircraft within 200 yards of a burst faced potential destruction from scything metal fragments. Hoffmann's gun crew had perfected the complex choreography required for effective anti-aircraft fire against high-altitude bomber formations. The 11-man crew included the gun commander, 2 loaders, a fuse setter, 4 ammunition handlers, and 3 operators for the prediction equipment that calculated firing solutions based on target altitude, speed, and direction. The Kommandojurat analog computer system allowed multiple guns to concentrate fire on specific points in space where intercepting aircraft would fly, creating lethal zones of exploding steel fragments. By February 1944, The technological balance was shifting decisively in favor of Allied strategic bombing forces. The introduction of the North American P-51 Mustang long-range escort fighter had revolutionized daylight bombing operations by providing fighter protection throughout the entire mission profile. The P-51's advanced Packard-built Merlin engine and laminar flow wing design gave it sufficient range to escort bombers to targets deep inside Germany and engage Luftwaffe interceptors on equal terms. Captain Robert Johnson of the United States Army Air Force's 56 Fighter Group flew P-47 Thunderbolt escort missions with the bomber formations attacking German aircraft factories during Big Week. Johnson's Republic P-47D carried 850 caliber machine guns and external fuel tanks that extended its combat radius to over 400 miles, allowing sustained escort operations over Germany. The psychological impact of having little friends alongside the bomber formations was enormous, as B-17 and B-24 crews no longer faced the terror of flying unescorted through German fighter defenses. The combined bomber offensive had become a war of industrial attrition, with Allied production capacity systematically overwhelming German manufacturing capabilities. American aircraft factories produced over 96,000 aircraft in 1944, while British production added another 26,000 aircraft to Allied strength. German aircraft production peaked at approximately 40,000 aircraft in 1944, but raw numbers told only part of the story, as bombing damage forced dispersion of manufacturing facilities and reduced efficiency throughout the German aviation industry. Flight Sergeant David Richardson piloted his Avro Lancaster City of Lincoln through the darkness above the Ruhr Valley, navigating by radar landmarks and dead reckoning toward the Messerschmitt assembly plant at Augsburg. Richardson's bomber carried 14,000 pounds of high-explosive and incendiary bombs in its cavernous bomb bay, representing the maximum load for the 1,700-mile round-trip mission. The Lancaster's unobstructed bomb bay design allowed it to carry larger bombs than any other Allied bomber, including the massive 12,000-pound tallboy and 22,000-pound Grand Slam earthquake bombs designed by Barnes-Wallis. The precision required for effective strategic bombing demanded constant technological innovation and tactical refinement. American bombardiers trained extensively with the Norden bombsight, a gyroscopically stabilized optical instrument coupled to an analog computer that calculated bomb release points based on altitude, airspeed, wind conditions, and ballistic characteristics. The bombsight remained classified at the highest security levels throughout the war, with bombardiers sworn to destroy the device rather than allow capture by enemy forces. German industrial planners struggled to maintain aircraft production under increasingly intense Allied bombing pressure. Albert Speer, Reich Minister of Armaments and War Production, implemented dispersal programs that scattered manufacturing operations across hundreds of smaller facilities, underground factories, and concealed production sites. While these measures complicated Allied targeting, they also reduced efficiency and complicated logistics throughout the German war economy. The human cost of strategic bombing operations was staggering for both sides. 8th Air Force bomber crews faced statistical odds that made tour completion unlikely, with casualty rates exceeding 80% for airmen serving in 1943. In the first half of 1944, casualty rates for every 1,000 American bomber crewmen serving 6 months in combat included 712 killed or missing and 175 wounded, representing an 89% casualty rate. Barely 1 in 4 American airmen completed their initial 25 mission tours over Germany. Unteroffizier Klaus Weber serviced Messerschmitt Bf 109 fighters at Jageschwader 11's airfield near Darmstadt, watching German fighter strength erode under the relentless pressure of Allied bombing and combat losses. Weber's unit had received 16 new Bf 109G fighters in January 1944, but combat losses and mechanical failures had reduced their strength to just 8 operational aircraft by February. Replacement pilots arrived with minimal training, many having less than 50 flying hours in type compared to the 200-plus hours considered necessary for combat effectiveness. The technological sophistication of Allied bombing operations extended far beyond individual aircraft and weapons systems. The strategic bombing offensive required unprecedented coordination between intelligence agencies, weather services, target analysis units, and operational commands. Mission planning incorporated detailed studies of German industrial capacity, transportation networks, and resource flows, identifying bottleneck targets where precision attacks could produce maximum disruption to enemy war production. British Royal Air Force intelligence units maintained detailed target folders for every significant industrial facility in German-occupied Europe, including floor plans, production schedules, vulnerable points, and defensive arrangements. American target analysis groups used statistical methods to calculate the probability of mission success, expected losses, and optimal attack profiles for specific target categories. The scientific approach to strategic bombing represented a revolution in military planning and operational research. Master Sergeant Frank Murphy served as navigator aboard the B-17F Argo of the 100th Bombardment Group, known throughout the 8th Air Force as the Bloody 100th, due to its exceptionally high combat losses. Murphy's crew represented the demographic reality of strategic bombing. Young men, most still teenagers, operating complex military technology under conditions of extreme stress and mortal danger. The average age of bomber crews was 22 years, with many gunners and specialists barely old enough to vote. The 100th Bombardment Group's operational history illustrated the brutal mathematics of strategic bombing operations. Between June 1943 and May 1945, the group flew 306 combat missions, dropped 19,257 tons of bombs, and lost 177 aircraft with their crews. The group's casualty rate exceeded 200%, meaning that statistically, every aircrew position was filled more than twice during the war due to combat losses, completing tours, and medical casualties. German radar technology had evolved significantly since the early war period, with Würzburg Reese installations providing precise tracking data on incoming bomber formations from distances exceeding 150 kilometers. The radar data fed into the Kammhuber Line, a sophisticated air defense network that divided German airspace into zones controlled by specific fighter units and flak batteries. As Allied bomber streams entered German airspace, radar operators vectored interceptor aircraft toward optimal attack positions while calculating firing solutions for anti-aircraft artillery. Oberleutnant Heinz Bahr of Jagdgeschwader 1 lifted his Focke-Wulf FW-190A8 from the runway at Rhein Airfield, climbing rapidly toward the altitude where American B-24 Liberator formations approached the Osnabrück Railroad marshalling yards. Bahr carried 4 20mm MG-151/20 cannons and 2 13mm machine guns, representing the heaviest armament available to German single-engine fighters. Despite this firepower, Luftwaffe analysis indicated that destroying a 4-engine bomber required an average of 20 cannon hits, demanding precise marksmanship and sustained fire at close range. The consolidated B-24 Liberator formations that Bahr intercepted represented the most numerous American bomber type, with 18,482 aircraft produced during the war. The B-24's high-efficiency Davis wing provided superior speed and range compared to the B-17 Flying Fortress, making it the preferred heavy bomber for long-range operations in the Pacific Theater and Mediterranean campaigns. However, the Liberator's complex flight characteristics and reduced survivability under combat damage made it less popular with European theater crews, who generally preferred the rugged reliability of the Boeing B-17. Staff Sergeant Anthony Bartolo manned the ball turret gunner position aboard the B-24J Witchcraft of the 467th Bombardment Group, suspended in the transparent Sperry ball turret beneath the aircraft's belly during the bombing run over German aircraft factories. Bartolo's cramped position provided panoramic views of the air battle, watching Luftwaffe fighters attack the bomber formation while 88mm flak bursts created deadly clouds of steel fragments at their altitude. The ball turret gunner position was among the most dangerous aboard heavy bombers, with no escape route if the aircraft was severely damaged. German aircraft manufacturing had dispersed across hundreds of facilities by early 1944, but the concentration of specialized equipment, skilled labor, and critical materials still created vulnerable bottlenecks for Allied targeting. The Messerschmitt factories at Regensburg and Wiener Neustadt, Focke-Wulf plants at Bremen and Marienburg, and Junkers facilities at Dessau represented primary objectives for the systematic destruction of German fighter production capacity. The precision bombing doctrine developed by American air planners assumed that destroying key industrial facilities would create cascading effects throughout German war production. Ball-bearing factories at Schweinfurt supplied components for aircraft engines, tank transmissions, and submarine motors, making them high-priority targets for sustained attack. Similarly, Synthetic fuel plants provided aviation gasoline essential for Luftwaffe operations, while aluminum refineries supplied raw materials for aircraft construction. Flight Lieutenant Robert Doe of the Royal Air Force 611 Squadron flew his Supermarine Spitfire 9 as escort for Lancaster bomber formations attacking German targets during coordinated day and night operations. The RAF had initially resisted escort fighter development, believing that single-engine fighters lacked sufficient range for deep penetration missions. However, the success of American long-range escorts prompted British development of extended-range Spitfire variants and eventual adoption of the North American Mustang for RAF Bomber Command operations. The technological innovation driving strategic bombing effectiveness extended beyond aircraft and weapons to include electronic warfare systems, navigation aids, and target marking techniques. American bombers carried increasingly sophisticated radar jammers, including carpet and mandrel systems that disrupted German radar-controlled flak and night fighter interception. British bombers used oboe and G radio navigation systems for precise position finding during night operations, while colored target markers allowed Pathfinder aircraft to designate aiming points for following bomber waves. Hauptmann George Peter Eder commanded the Luftwaffe's first operational jet fighter unit, Kommando Norden, equipped with Messerschmitt Me-262A Schwalbe aircraft capable of intercepting Allied bombers at unprecedented speeds. The Me-262's 430 million Malawian Quach's 108 cannons could destroy heavy bombers with brief firing bursts, while its 540 miles per hour maximum speed allowed attacks from angles impossible for conventional piston engine fighters. However, the jet fighter's complex maintenance requirements, fuel limitations, and developmental problems prevented large-scale deployment before Germany's defeat. By March 1944, the combined bomber offensive was achieving its primary strategic objectives despite continuing heavy casualties among Allied aircrew personnel. German aircraft production, while still substantial in absolute terms, was declining relative to projected requirements as bombing damage forced constant facility relocation and repair. More importantly, the quality of German pilot training was deteriorating as fuel shortages reduced flying hours, and experienced instructors were killed or wounded in combat operations. Staff Sergeant Eugene Fletcher served as flight engineer and top turret gunner aboard the B-17G Shoo Baby of the 91st Bombardment Group, monitoring engine performance and operating defensive armament during missions over heavily defended German industrial targets. Fletcher's position required technical expertise in aircraft systems, aerial gunnery skills, and the psychological resilience to function effectively under extreme combat stress for missions lasting 8 to 10 hours. The industrial mobilization supporting strategic bombing operations represented one of the largest technological enterprises in human history. American aircraft production required over 2 million workers in airframe manufacturing, engine production, and component fabrication. The Boeing B-17 program alone employed 100,000 workers at 3 major assembly plants, while subcontractors supplied everything from bomb sights and turret systems to radio equipment and survival gear. German flak defenses had become increasingly sophisticated and deadly as the war progressed, with over 1 million personnel manning anti-aircraft guns, searchlights, and radar systems by 1944. The 88mm flak guns defending major industrial targets were integrated into fire control networks that allowed simultaneous engagement of bomber formations from multiple angles. Coordinated flak fire could create lethal barrages covering cubic miles of airspace, forcing bomber formations to fly through predetermined killing zones during their attack runs. Oberstfreiter Rudolf Kessler operated a Würzburg-Reese radar installation providing target data for 88mm flak batteries defending the Messerschmitt factory complex at Augsburg. Kessler's radar could track individual aircraft at ranges exceeding 70 kilometers, measuring altitude, heading, and speed with sufficient accuracy to calculate precise firing solutions for anti-aircraft artillery. The radar data was transmitted to gun batteries via telephone lines, allowing coordinated engagement of bomber formations before they reached their target areas. The strategic bombing campaign had evolved into a contest between technological innovation and industrial capacity, with both sides constantly developing new weapons, tactics, and countermeasures. Allied electronic jamming systems reduced the effectiveness of German radar-controlled defenses, while German jets and rocket-powered interceptors threatened to neutralize Allied bombing operations. However, the mathematical realities of production capacity, pilot training, and fuel availability increasingly favored the Allies as the war continued. Flying Officer James Morrison piloted his Avro Lancaster Phantom of the Ruhr on the March 1944 raid against the Messerschmitt component factory at Obertraubling, carrying specialized bunker-busting bombs designed to penetrate reinforced concrete construction. Morrison's crew had trained extensively for precision attacks against hardened targets, using modified bombing techniques and specialized ordnance to maximize damage against underground and protected facilities. The Lancaster bomber formations approaching German targets represented the culmination of British night bombing technology and tactics. Royal Air Force Bomber Command had developed sophisticated pathfinding techniques using radar navigation, target marking pyrotechnics, and master bomber aircraft that coordinated attacks in real time. The precision achieved by RAF night bombing operations by 1944 rivaled that of American daylight attacks, while maintaining the survivability advantages of darkness operations. German jet aircraft development represented a final technological attempt to regain air superiority over the Reich, but fuel shortages, pilot training deficiencies, and production bottlenecks prevented effective deployment. The Messerschmitt Me-262 required rare metals and specialized manufacturing techniques that were increasingly unavailable as Allied bombing disrupted German industrial capacity. More critically, the synthetic fuel production essential for jet operations had become a primary target for Allied strategic bombing. Lieutenant Colonel James Doolittle assumed command of the 8th Air Force in January 1944, implementing tactical changes that revolutionized American daylight bombing operations. Doolittle authorized P-51 Mustang escort fighters to leave bomber formations and actively hunt German interceptors, transforming defensive escort missions into offensive fighter sweeps that systematically destroyed Luftwaffe air superiority over Germany. The P-51 Mustang represented the technological breakthrough that made sustained daylight bombing feasible deep inside German territory. The aircraft's Packard-built Rolls-Royce Merlin engine and laminar flow wing design provided exceptional range and performance at high altitude, while 650 caliber machine guns delivered devastating firepower against German fighters. With external fuel tanks, P-51 formations could escort bombers to Berlin and return to England, providing continuous protection throughout the mission profile. Sergeant Robert Rosenthal served as bombardier aboard the B-17G Rosie's Riveters of the 100th Bombardment Group during the systematic campaign against German aircraft manufacturing facilities. Rosenthal operated the top-secret Norden bombsight, calculating wind drift, altitude corrections, and bomb ballistics to achieve precision attacks on specific industrial buildings within large factory complexes. The bombardier's skill directly determined mission effectiveness, as strategic bombing required accurate placement of ordnance on designated targets. The Norden bombsight represented one of the most closely guarded technological secrets of World War II, incorporating gyroscopic stabilization, optical magnification, and analog computing capabilities that enabled unprecedented bombing accuracy. The device automatically controlled aircraft flight during bomb runs, flying the bomber along precisely calculated approach paths while the bombardier fine-tuned aiming corrections. Security procedures required bombardiers to destroy the bombsight rather than allow capture by enemy forces. German industrial dispersal programs had created a cat-and-mouse game between Allied intelligence and German production planners, with constant relocation of manufacturing equipment forcing continuous updates to target databases. Underground factories, camouflaged facilities, and widely scattered component production complicated Allied targeting while reducing German manufacturing efficiency. The net effect was a gradual degradation of German aircraft production quality and quantity throughout 1944. Flight Sergeant Michael O'Brien flew his Avro Lancaster Dublin Daredevil on the coordinated night attack against the Focke-Wulf assembly plant at Marienburg, part of the systematic campaign to destroy German fighter production capacity. O'Brien's bomber carried a mixed load of high-explosive and incendiary bombs designed to create sustained fires in aircraft manufacturing facilities, where aluminum construction and fuel storage created ideal conditions for devastating conflagrations. The technological sophistication of Allied bombing operations by 1944 included weather forecasting services, photo reconnaissance units, damage assessment capabilities, and target intelligence networks that provided detailed information about German industrial capacity. Mission planning incorporated meteorological data, enemy fighter strength estimates, flak battery locations, and industrial production schedules to optimize attack effectiveness while minimizing Allied losses. Master Sergeant Charles Luckadoo piloted the B-17G Piccadilly Lily of the 100th Bombardment Group during the March 1944 mission against the Messerschmitt factory at Regensburg, leading a combat box formation of 18 Flying Fortress bombers through intense German fighter opposition. Luckadoo's aircraft sustained severe battle damage from cannon fire and flak fragments, but the B-17's legendary toughness allowed the crew to return safely to England despite massive structural damage. The Boeing B-17 Flying Fortress had developed a reputation for exceptional survivability under combat conditions, with numerous documented cases of aircraft returning to base despite catastrophic damage. Stories circulated throughout the 8th Air Force of B-17's landing with tail sections nearly severed, engines destroyed, and control surfaces shot away. The aircraft's robust construction, redundant systems, and fail-safe design philosophy allowed crews to survive battle damage that would destroy other bomber types. German fighter pilot training had deteriorated significantly by early 1944 as fuel shortages reduced flying time and experienced instructors were killed or wounded in combat. New Luftwaffe pilots arrived at operational units with as few as 50 flying hours compared to the 200-plus hours considered necessary for combat effectiveness. The training deficit created a downward spiral as inexperienced pilots were shot down quickly, preventing the accumulation of unit expertise necessary for effective fighter operations. Oberfeldwebel Johann Muncheberg piloted his Focke-Wulf FW-190A8 on what would prove to be his final interception mission against American B-24 Liberator formations attacking German aircraft factories. Muncheberg carried the heaviest armament available to German single-engine fighters, including 420mm cannons and 213mm machine guns, but Luftwaffe tactical analysis indicated that even experienced pilots required close-range attacks lasting several seconds to achieve bomber kills. The mathematical realities of air combat heavily favored Allied strategic bombing operations by 1944, as German fighter production could not replace combat losses while Allied bomber and fighter production continued increasing. American aircraft factories delivered over 96,000 military aircraft in 1944, while German production peaked at approximately 40,000 aircraft. More critically, Allied pilot training programs produced experienced aircrews faster than German training systems could replace combat losses. Flight Lieutenant William Reid piloted his Avro Lancaster Spirit of Scotland during the coordinated attack on the Junkers aircraft factory at Dessau, part of Operation Point Blank's systematic destruction of German fighter production capacity. Reid's bomber carried the maximum bomb load of 14,000 pounds for the 1,400-mile round-trip mission, representing the outer limits of Lancaster operational range with full ordnance loads. The strategic bombing campaign had achieved decisive results by April 1944, with German aircraft production falling significantly below projected requirements despite heroic efforts by German industrial managers and workers. Ball bearing production at Schweinfurt had been reduced by 67% through sustained bombing, while synthetic fuel plants producing aviation gasoline suffered devastating attacks that crippled Luftwaffe training operations. Staff Sergeant Donald Miller served as radio operator aboard the B-24J, Liberating Lady, of the 389th Bombardment Group during the final phase of Operation Point Blank, monitoring German fighter communications while coordinating with escort fighters during bombing missions over German industrial targets. Miller's position required technical expertise in radio systems, German language skills for intelligence gathering, and the ability to function effectively during intense combat operations. The electronic warfare dimension of strategic bombing had become increasingly sophisticated, with both sides developing jamming systems, navigation aids, and communication security measures. American bombers carried window chaff dispensers that created false radar targets, while German radar operators developed techniques to distinguish actual aircraft from electronic deception. The technological competition extended to every aspect of strategic bombing operations. By May 1944, the combined bomber offensive had achieved its primary strategic objective of establishing Allied air superiority over Western Europe, enabling the successful execution of Operation Overlord. On D-Day, June 6, 1944, the Luftwaffe managed only 319 sorties against 14,674 Allied sorties, demonstrating the complete collapse of German air resistance over the invasion beaches. The strategic bombing technology developed during World War II revolutionized military aviation and established the foundation for Cold War nuclear deterrence strategies. The precision bombing concepts, long-range escort tactics, and industrial targeting methodologies pioneered by Allied air forces became standard doctrine for strategic air operations. The B-17 Flying Fortress, B-24 Liberator, and Avro Lancaster bombers had proven that coordinated air power could systematically destroy enemy industrial capacity and achieve decisive strategic results. Captain Robert Morgan piloted the B-17F Memphis Belle during the final mission of his crew's 25-mission combat tour, representing one of the first complete bomber crews to survive the statistically impossible odds of strategic bombing operations over Nazi Germany. Morgan's achievement became a symbol of American determination and technological superiority, demonstrating that precision daylight bombing could achieve decisive results despite enormous casualties and technological challenges. The legacy of strategic bombing technology extended far beyond World War II, influencing post-war aircraft development, nuclear weapons delivery systems, and military aviation doctrine. The industrial mobilization required to support strategic bombing operations established the foundation for American aerospace dominance, while the technical innovations developed during the combined bomber offensive enabled the rapid deployment of intercontinental ballistic missiles and space exploration programs. The human cost of strategic bombing operations remains staggering for both sides, with over 55,000 Allied aircrew killed in European theater operations and hundreds of thousands of German civilians and industrial workers killed in bombing raids. The technological revolution that enabled precision strategic bombing had achieved its military objectives, but at a cost that demonstrated the devastating potential of industrial warfare conducted from the air. The Boeing B-17 Flying Fortress, Consolidated B-24 Liberator, and Avro Lancaster bomber aircraft had successfully demonstrated that coordinated strategic bombing could achieve decisive results against industrial targets, paving the way for Allied victory in Europe. The precision bombing technology, formation tactics, and industrial targeting strategies developed during the combined bomber offensive established the foundation for modern strategic air power and proved that technological superiority, properly applied, could determine the outcome of global conflicts. The systematic destruction of German aircraft manufacturing capacity through strategic bombing operations represented one of the most successful applications of air power in military history, achieving decisive results that enabled Allied ground operations while demonstrating the revolutionary potential of precision strategic bombing technology.